Hello everyone, I am Mallikarjuna Rao Mudigonda. I'm the Technical Marketing Engineering Leader in the Data Center Business Unit. In this video, I'm going to talk about how to build high available active clusters with 3 Linux machines for the Nexus Data Broker product. The NDB version that I choose for the demonstration is 3.10.4. The agenda for this recording is going to be how to build an active cluster with 3 Linux machines and how a typical topology will look like. And we will dig deep into some of the VM details for building the cluster. And we will see what is the installation process to build a 3-node HA cluster and what are the configuration parameters we need to enable and what are the possible cluster issues that you might encounter on the field. So this is the topology. As you can see here, on the right hand side we got the tools, on the left hand side we got the production network. And the very important things that we may want to focus here is the 3 Linux machines which are used to build an active cluster, which are labeled as P. P refers to primary, M1, which is called a member 1, and M2, which is a member 2. The 3 Linux machines are teamed up to form an active cluster. The technology that we use in Nexus Data Broker to build the active cluster is InfiniSpan technology, which is open source technology. The cluster which is built with 3 Linux machines is managing 2 NDB switches, which are NDB switch 1 and NDB switch 2. And the way how these are connected is through management interface. You don't need a direct connectivity between the servers. As long as the VMs are able to ping each other, they're on the same subnet, they can ping each other, the cluster can be formed between the 3 Linux machines. Ubuntu is the distribution that I picked for this experiment. And here are some of the VM details. And in the customer deployment field, it need not be Ubuntu. It can be CentOS, Red Hat, or it can be Fedora. Whatever distribution can be of your choice. Here is the installation steps. To begin with, first we start the NDB installation on the primary server. Go to the NDB primary server, copy the software, and probably do the MD5 checksum to ensure the software is properly installed. And then the software comes with a shell script, and this comes as a zip file. Use the unzip utility on the Linux machine and unzip the software. So later, to begin the process of building the cluster, there is a config.ini parameter in the NDB configuration directory, and there is a super nodes flag in config.ini file. And you need to populate the super nodes flag as shown here with all the 3 IPs of the Linux machines. As you can see, IP1 is my primary IP address, and IP2 is my member 1's Linux machine IP address, and IP3 is my Linux machine member 2 IP address. So the first one is the preferred primary node. That server acts as the primary. And the second IP address and the third IP address take the role of M1 and M2, which are member 1 and member 2. A few things to bear in mind here. For the active cluster to work, please ensure that the firewall between these Linux machines is not blocked. What I mean by that is the 12,000 and 12,001 are the gossip router ports, which are important for the InfiniSpan cluster to work and function. Please ensure that these ports are not blocked. So once after we copy the software, and what we do is, it comes with a shell script, and using the shell script, we are going to start the NDB controller on the primary node. A quick call out here, if your servers are talking to the NDB switches using TLS, please ensure you're going to start the controller with the TLS key store and the trust store as shown in the step 2. And verify if the controller is running with ps-ef grep java command to ensure the NDB controller is running on the primary server. So on the UI, once you log in on the UI, the first thing what you notice here is the very important banner is primary is ready and please bring up the members. So it's going to give you a clear instructions on what step to do once after the primary is started. As you notice on the right hand corner, there is a icon with P. P refers to the primary node, and the little red color what you see in the under subscription of the P is going to be a read-only mode. Right now, as you can see, the controller is only on the read-only mode. So now you go to the member 1 and do the same process what we did to the primary. We copy the software, we ensure the MD5 sum is right, and we use the shell script, and we point to the TLS key store and trust store, and we start the controller. And now the member 1 controller is accessible on the URL as shown here. So once you log in into the member, there are few interesting information on the right hand corner. Now the cluster is in the formation state. As you can see, the P is now transitioned into M because you are accessing this controller on the member server. M refers to the member server. As indicated, there are two Linux machine IP addresses. The star indicates that it's a primary server IP and the member doesn't have any star. So what is happening on the primary node when this member controller is coming up? The primary node, when you try to log in, it is still in the read-only mode and it is still in the formation state as indicated in the LO, and it clearly calls out that the cluster is syncing. So right now it's not advised to do any configurations on the primary because the cluster is still in the syncing state. It might take few minutes for the member controller to show that NDB is ready for the configurations. Now on the primary controller, as you can see, now the NDB is ready for the configurations. So now you go to the member 2, which is the last Linux machine, and use the same process, use the same script to start the controller. And once you log in into the controller, so it clearly indicates that the cluster is syncing, and on the right hand corner you can see that it's in green state and it is showing as free. Right now you are logged in on the primary, which is indicated as a star, and there are two members, which is a full healthy cluster, and it is just in the syncing state. Allow a few minutes for the cluster to sync completely. Once the cluster is all synced between all the three Linux machines, as you can see here, the NDB is ready for all the configurations, and now as you can see on the state, it's completely in the green color. This is the very good state for all the configurations to begin with. Either defining the port, creating a connection, adding the tool, all the operations can be done when the cluster is ready for all the configurations. And on the operational side, there could be some possible issues when the VMs are not reachable. So when the VMs are not reachable, the possible situations can be the ports are blocked, the gossip router ports are blocked, or there could be a firewall completely blocking all the conversations in your network between the Linux machines. And the other scenario, what happens is a split brain scenario. So under rare circumstances, what happens is all these Linux machines will eventually do as a triple primary. So all these three Linux machines will turn into primary and they start managing the NDB switches simultaneously. And this situation is going to create a lot of inconsistencies on the configurations on the NDB boxes. At this stage, NDB controller, to avoid this kind of catastrophic actions, the controller is now put in read-only mode so that the users are not allowed to log in into the configurations to do any of the inconsistent configurations at this bad state. Thank you.